This is the Edexcel IGCSE January 2020 chemistry paper. This is suitable for those taking both double and triple award. Question 1. The diagram shows the particles in the atom of an element. Particle Y is a proton. What is particle Z? So, to answer this question, we need to revise the subatomic particles. These are the particles that are found inside an atom. They include protons, neutrons, and electrons. So, the protons and the neutrons, they are in the nucleus. That is this bit over here. Whereas the electrons, they are in the shells. So this element has two shells. So if particle Y, which is the white circle, is a proton, what is particle Z, which is the black circle? Who's the other thing that's inside a nucleus? That would be a neutron. Question B, which of these has the smallest mass? So we need to know their relative mass. The relative mass of a proton is 1. For neutron, also 1. For electrons is 1 divided by 2,000. That's a really small number. That means an electron is about 2,000 times lighter in mass than a neutron or a proton. So therefore, the one with the smallest mass would be an electron. C, what is the mass number of this atom? Let's revise both mass number and atomic number because it's asked one after the other. So I'm just going to take an element from the periodic table completely by random. I'm going to take lithium. So in any element you find in the periodic table, you're going to see a big number. This big number is the mass number. And then the small number is called the atomic number. Now, the atomic number is equals to the number of protons. So lithium here has 3 protons. And if you remember, protons have a positive charge, and you need to cancel that out with an equal number of negative charge. Who has negative charge? Electrons, right? Electrons. So therefore, lithium also has 3 electrons. So when you see this 3, it equals to the number of protons and electrons. 3 protons, 3 electrons for lithium. So what about the mass number? If you remember, mass number is, well, it's mass. So who has mass? Look at what we just wrote up here. Who has mass? Protons and neutrons have mass, right? Because electrons are so light, they essentially have no mass. So protons and neutrons make up the mass of an atom. Therefore, the mass number is equals to the number of protons plus neutrons because they both have mass. And since protons is 3 in this case, and the total is 7, what would be neutrons then? It would be 4. So for lithium, it's got 3 protons, 3 electrons, and 4, which comes from 7 minus 3, 4 neutrons. All right, so knowing this knowledge now, let's go to this actual element and try to work out the number of protons, neutrons, and electrons. So protons, how many protons does it have? Let's count them. That would be the white circle. That's 1, 2, 3, 4. 4. Neutrons, count the black circles. 1, 2, 3, 4, 5. And electrons, which is equal to the number of protons because their charges need to cancel out, right? So therefore, electrons is also 4. And you can also count them here. 1, 2, 3, and 4. So what about the mass number and the atomic number? So if you remember, atomic number is equals to the number of protons. So this is the atomic number is 4. And then mass number, who has mass again? Protons and neutrons, which is 4 plus 5. 9 is equals to the mass number. Mass number. Okay. So mass number would be 9. Atomic number would be 4. Identify the element that contains this atom. So we just need to go to the periodic table and find who has a mass number of 9 and an atomic number of 4. That would be beryllium. Beryllium. Okay. State what is formed when this atom loses its outer shell. Electrons. So beryllium is in group 2. Group 2 is equals to 2 electrons in the outer shell. That's what the group number means, okay? 2 electrons in outer shell. So it's going to lose these 2 electrons because it needs to get a full shell. 2 electrons is not a full shell, it's not stable. So it's going to lose 2 electrons. And when it loses these 2 electrons, think about what happens to its charge. Originally, beryllium is an element, so it's got no charge. It's got neutral charge. And if you're neutral, and then you go and lose 2 negative electrons, what does your charge become? It will become positive, right? So you would write a beryllium ion. You should also say positive ion or positive ion. And just to take this a step further, what would be the charge on the beryllium? Think about it. How many electrons has it lost? It's lost 2 electrons, right? If it loses 2 electrons, it will have a charge of positive 2. So it'll be Be2+. Okay, question 2. This question is about states of matter. The diagram shows how the particles of a substance are arranged in 2 different states. That would be solid and gas here. And it says, complete the diagram to show how particles are arranged in the liquid state. So there's a few key things I want you to focus on here. For the solid, it is arranged in a regular pattern, and they're touching. For the gas, it is arranged in an irregular pattern and definitely not touching because they have so much energy that they can be far away from each other. They can move away from each other. So for liquid then, it would be irregular but still touching because they don't have enough energy to be far away from each other. So let's draw it irregular, so no particular pattern, but they're touching each other. Please make sure that you actually touch the bottom and not just have these floating in the middle, because think about it, if this was a glass of water, the water would be touching the bottom of the glass, right? So make sure they're touching. Part 2, identify the state of matter in which the particles have the most energy. Which one looks, just look at it. Look at the diagram. Which one looks like it's got most energy? Which particles? It's got to be the ones that are flying around a lot more, right? So going this way, you have more energy. So that would be gas. Okay, part B. The state symbols, solid, liquid, gas, and aqueous, are often used in chemistry. The table shows some physical changes. Complete the table by giving the state symbol before and after each change. So let's revise changing between different states of matter. I've drawn here 3 states of matter in black: solid, liquid, and gas. Solid, liquid, and gas. I've used H2O here as an example. So you've got ice, water, and steam. And you can see the arrows here show you how it changes state. For example, when ice turns into water, that's from solid to liquid, that's called melting, and etc. Okay? So therefore, water evaporates. What is the state before it evaporates? Think about it. Water, is that liquid or solid or gas? That's definitely liquid, right? So before it evaporates, liquid, and then after it evaporates, is turned into, evaporate is the same as boiling, so it's turned into gas. Liquid to gas. Next one, crystals of iodine. Crystals. Okay, what is the state of crystals? What does that sound like? Crystal, solid, liquid, or gas? Solid, right? And if it's sublime, look, when a solid does sublimation, what has it turned into? It's turned into a gas. So this is from solid to gas directly. That's what sublime means, this word. And finally, ice melts. Ice, is that solid, liquid, or gas? Ice. That's solid. And when it melts, it turns into a liquid, which is water. Part C, explain why hot water evaporates more quickly than cold water. Why hot water evaporates more quickly than cold water. So one tip when you do exams is, if you're a little clueless, scroll back up and look at how the question can help you to answer. This is the last part of question 2, right? So there must be something in the previous parts that can be helpful to you. So let's scroll back up and just take a look. Water into gas. If this is hot water, how come it evaporates faster than cold water? Think. If it is hot water, these water molecules if they're hot, they have more kinetic energy. If they have more kinetic energy, they're able to break apart these attractive forces that are holding them together. And once they break apart, they've become a gas. Okay, so the point here is energy. Hot water has more energy, therefore it can break the attractive forces holding the water molecules together and therefore become a gas or evaporate into a gas faster. So the key word here is energy. Hot water has more energy, which is able to break the attractive forces holding. Don't use vague words like them or it. Holding what? Give me the actual noun. Holding the water molecules together. Therefore, evaporating faster. Now, how to make this answer better? Notice the question says, why does hot water evaporate more quickly than cold water? So make sure your answer also compares to cold water. So I should write hot water has more energy than cold water to show them you are aware of the comparison. Okay? All right. Question 3. The group 7 elements are called halogens. Halogens form compounds called halides. 3 of the halogens are represented by the formula X2, Y2, Z2. And it says solutions of these halogens are added separately to solutions of sodium halides. Sodium is Na, so NaX, NaY, Naz. And the table shows whether or not a reaction occurs. And you're supposed to work out who is the most reactive and who is the least reactive. So let's, first of all, make sure we know who are the halogens. Halogens are in group 7, so it's all here. Do you see that? Fluorine, chlorine, bromine, iodine, and astatine. These are the halogens. What is the difference between halogens and halides, by the way? A halogen is, for example, if I pick chlorine, right? This is a halogen, Cl. Chloride, which is a halide, this is chlorine. Chloride is the ion, okay? So chloride is after it has gained 1 electron. Why gain 1 electron? Because chlorine is in group 7. How many do you need to gain to get a full shell? 8 is a full shell, so 7 plus 1 is 8. It needs to gain 1 electrons to get that full shell. That's why it's 1 negative, because it's gained 1 negative electron. So halogen is just the element, and the halide is the ions made from the elements. Okay, all right. So you can see here that the halogens are these ones up here. It's just the element, whereas the halides, they are here, right? Because this would be NaX minus, because Na is positive, that means Y is negative. So these are the halides. Okay, so now that we've revised that, let's talk about the actual question. Use the information in the table to deduce the order of reactivity of the halogens. So you need to think very systematically. You need to think, why is there yes and no in this table? So why is there no reaction for this column? There's only 2 reasons that something would not react. Either it is not reactive enough, or it will not react with itself. So this first no is because X2 is not going to react with itself. It's not going to react with X. So that's why this is no. What about these 2 no's? X2 is not reactive enough to react with NaY. That's why there's no reaction. Similarly, X2 is not reactive enough to react with Naz, which is Z here. So that's why there's no reaction. So from this, we can figure out that X is very unreactive, isn't it? Because it's not able to react with Y or Z. All right, so next column, this one. Y2, how come it can react here? Yes, think about it. If Y can react with X, that means Y's got to be more or less reactive than X. It's got to be more reactive than X, right? That's why it can react. It can kick out, displace the X. Therefore, Y2 has got to be more reactive than X2. Would you agree? Okay. Now, how come this is no reaction? Well, look at it. What's reacting? The Y2 and the Y. They're not going to react with themselves. That's why there's no reaction. Now, how come there's no reaction here? That's because the Y2 is not reactive enough to displace the Z. That's why it doesn't react. So finally, the last column, why does Z2 react with X? Because it's more reactive than X. So definitely Z is above X somewhere here. Z2 somewhere here, right? Then look at this. Z2 can also react with Y. It kicks out, it displaces the Y. And if it displaces the Y, you can conclude that Z is more reactive than Y. So I would put Z up here. And by the way, why is this no reaction? Have a think. Look at what's reacting. Exactly. It's not able to displace itself. Z2 is not going to react with itself. Okay, part B. An aqueous solution of halogen Y2 is orange. This solution is decolorized when it reacts with an alkene. Deduce the identity of halogen Y2. So to revise this, we need to know what an alkene is. An alkene is an unsaturated hydrocarbon. What does unsaturated mean? It means that there is a double bond. Okay, there's a double bond. So I'm going to have an example to show you. Let's pick ethene. Ethene is an alkene. If you still remember, the general equation of ethene, of alkenes is CnH2n. So ethene, eth means 2 carbons, so this will be C2H4, right? So I'm going to draw C2H4 with a double bond in the middle because it's an ene, it's an alkene, it's got a double bond, and you've got the 4 hydrogens around it. Then I'm going to add this orange Y2, okay? I'm going to add the orange Y2, Y2, I'm going to join them up like that. What's going to happen is that you can imagine this double bond, it's like your arms folded up. If you can fold up your arms, you can open up your arms, right? So you've opened up your arms, and each one of your arms is now going to grab onto a Y like that. So the product would be, the arms have opened up, so there's no more double bond. The 4 H's are still there because they haven't gone anywhere, so let's have the 4 H's there. And then now you're going to add on the 2 Y's. See that? You're going to add on the 2 Y's because you've opened up the double bond. Now, why am I talking about this? Because the color is important. What's the color of this? It tells you it is a orange solution. This is an orange solution. So before there's an orange solution, what about afterwards? Look at the product. Look at the product. Does the product have any color here, this product? Is there still Y2 left? Is Y2 still a thing? No, it's not. And if it's not, then it would be colorless. That's why it's decolorized. It's turned from orange to colorless. So the point about this question is that it tells you there was a orange solution, which is Y2, and once it's added to the alkene, it's turned colorless. This proves that there's an alkene there because only alkenes have the arms to open up and grab onto the 2 Y's. There's no more Y2 after the reaction, right? This is the only Y2 in the whole reaction. So who's the identity of halogen Y2? This comes back to your knowledge of the halogens. You need to know that, remember the halogens are here, right? Fluorine, chlorine, bromine, iodine. Bromine is actually a brown liquid or an orange-brown liquid. So this bromine, Br2. Okay, part C, the table shows some physical properties of the halogens. Complete the table by predicting a boiling point for chlorine, the state of fluorine at room temperature, and the color of astatine. Basically, fill in these 3 gaps. Look at the pattern. That's how you do chemistry. There's always some sort of trend, okay? So look at the trend. Let's start with the colors because it's the easiest. Look at the colors going down, okay? As you go down, you go from yellow to green to red, brown to gray. So what's the color trend? I would say it's getting darker, right? So what's darker than gray? It's got to be black, yeah? Same thing for this. Look at the trend. Look at the trend, okay? Let's go up this time because the top one is missing, right? So we're going from solid to liquid to gas. So what would you say this one is if you could keep up with the trend? It's got to be a gas as well, right? It's not gonna go back into a liquid or a solid. And lastly is the boiling point. Look at the boiling point. As you go down the group, what happens to the boiling point? It gets higher and higher and higher, right? It gets higher. So that means this number has got to be between this number and this number. That's logical, right? So I can pick any number that's between -188 and 59. I can pick, for example, 20 degrees Celsius. By the way, why does the boiling point increase as you go down group 7? Because the intermolecular forces are getting stronger, okay? The intermolecular forces are getting stronger. Intermolecular forces. Okay, right. Part 2, why do the halogens have similar chemical properties? Okay, guys, when you hear the word chemical property, you need to think group number, okay? Group number. So chemical properties, halogens, right? Group 7. So chemical property is related to the group number. What do we know about group number? Group number is equals to the number of electrons in the outer shell. Why is that a chemical property? Because think about it. The number of electrons in the outer shell dictates how you react, how you behave chemically, how you react, how you gain or lose electrons. So if you have 7, everyone in this group have 7 electrons in the outer shell. So you would agree that they all react by gaining 1 electron to get 8 electrons in the outer shell, right? So that's why they have the same chemical or similar chemical properties, because they all react by gaining 1 electron, because they all have 7 electrons in the outer shell, which is answer C. They have the same number of electrons in the outer shell. So when you see chemical property, think electrons in the outer shell. Question D, a teacher uses this apparatus to demonstrate the reaction between chlorine gas and iron wool. The teacher does the reaction in a fume cupboard. Suggest why the teacher does the reaction in a fume cupboard. It's because chlorine is a toxic gas. You don't want to breathe that in. The fume cupboard will suck away all the toxic gas, so it doesn't actually come into the laboratory. Part 2, the product of the reaction between iron and chlorine is iron chloride. The ions in iron chloride are Fe3+ and Cl-. Use this information to give the chemical equation for this reaction. Okay, whenever you write reactions, don't be afraid, because it helps you. It really helps you. So get comfortable and always try to write more chemical equations. Try to predict what will happen, what would be the products that are produced. And in fact, this one's easy. They told you who are reacting. It says the reaction between iron and chlorine. So I would write that chemical equation. So make sure you don't write the actual word equation, chemical equation. So iron plus chlorine makes iron chloride, right? Iron chloride, that's FeCl. Now, the smart ones in the audience will notice something wrong. What is the mistake with what I've written? What is missing? I can see 2 mistakes. The first one is this chlorine. Chlorine will never be by itself, because if you remember, chlorine is in group 7, right? Group 7 means how many electrons in the outer shell? 7, right? 1, 2, 3, 4, 5, 6, 7. Is that stable? Is it? No, it's not, because it's not a full shell. So how do you get chlorine to be stable? You need to have another chlorine to share how many electrons? Share 1 electrons, because the chlorine on the left needs 1 more electron to have 8, right? And the chlorine on the right will also have 7 electrons in the outer shell. So count them. 1, 2, 3, 4, 5. How many do I need to draw more? 6, 7, right? 6 and 7. So guys, do you see how chlorine is always a pair? We call this a diatomic molecule, okay? Diatomic molecule. Because it's always, di means double. It's always a pair. So it should always be Cl2. This applies to many many of the non-metals that you guys know. Oxygen is O2, hydrogen is H2, right? All of the halogens are 2s, F2, Cl2, Br2, I2. Please remember the 2 because remember this diagram. They need that covalent bond. They need to share one with another one in order to have a stable outer shell. So it's going to be a pair, ACl2. Now, what's the next problem? Look at this one here. What is the charge? They even told you the charge is Fe3 plus, right? Fe3 plus. If it's Fe3 plus, what is the charge on a chloride? It also tells you -1. And you know they have to cancel each other out, right? So how can I combine them so that the 3 plus and the -1 will cancel each other out? How many chlorines do I need? Actually, that's a mistake. I should say how many chlorides will I need, right? Because it's chloride here, isn't it? Not chlorine. Chlorine is the gas. That's Cl2. Okay, so how many chlorides do I need over here? 3. Because 3 negatives will cancel out 3 positive, isn't it? Now, don't have these in there. Let's erase that because you don't want to confuse the examiner. So this would be the equation. So far, so good. What is the next step? This would only get 1 mark out of the 2 marks. Chemical equations ideally should always be balanced, right? So let's balance it. Let's balance it. So I am seeing 3 chlorides here. Whenever, one tip for balancing is that if you see a odd number, make it even because odd numbers are difficult to maneuver in a balancing equation situation. So always make this even. How do I make it even? I double it. I times 2. Try that. Any odd number, if you times 2, it will become even. Okay, 5 times 2 is 10, right? 3 times 2 is 6. So I'm going to times 2 by adding the big 2 in the front like that because that's how we balance equations, right? Add big numbers in the front. Big 2 over there. Now it's balanced. I mean, there's 3 chlorides times by 2 is 6. So how do I balance out the chlorides on the left-hand side to also get 6? Add a big 3, right? Add a big 3. And finally, how do I balance out the ions? There's 2 ions here, therefore I need to add a big 2 over here. So that would be the answer. 2Fe plus 3Cl2 makes 2FeCl3. So what topics have been covered in this paper so far? If you look at the red box, make sure you know what is a mass number, what is an atomic number, and what these numbers mean. The mass number is equals to the protons plus the neutrons, and then the atomic number is equals to the number of protons. And if you need to find the number of neutrons, you do 7 minus 3. That would be the number of neutrons. Blue box, this paper also looked at states of matter, especially with regarding to changing state, for example, melting, boiling, especially sublimation, which is less commonly seen. It is when a solid turns directly into a gas. That's called sublimation. And we also looked at the energy levels of solid, liquid, and gas. Remember, gases have the most energy, and solids have the least. Also pay attention to how you draw these diagrams, because on an exam, they could ask you to draw any one of them. Looking at the purple box, we also cover the periodic table, particularly with regards to chemical properties. So if a question asks about chemical properties, you're going to look at the group number, because the group number tells you the number of electrons in the outer shell, and that is the chemical behavior of the element, because it tells you how many electrons he will gain or lose when it reacts. Finally, the green box, which is on the halogens. The halogens is group 7 in the periodic table: fluorine, chlorine, bromine, iodine, and astatine. You need to know what they look like in terms of the color. So over here, fluorine is a yellow gas, chlorine is a green gas, bromine is a red-brown liquid, iodine is a gray solid, astatine is a black solid. Make sure you know their color and their state. And just appreciate as well their boiling point, which increases as you go down the group. Increases as you go down the group because the intermolecular forces are getting stronger. And then finally, the reactivity of the halogens. And this table is very important. I've put here in different colors because they tell you different things. The green color means there's no reaction because it will not displace itself. So X will not displace X, Y will not displace Y, and Z will not displace Z. That's what the green no means. The yellow no reaction doesn't mean the same thing. The yellow no reaction means X is not reactive enough to displace Y. That's why there's no reaction. Same thing, X is not reactive enough to displace Z, therefore there's no reaction. And in this case, Y is not reactive enough to displace Z. That's what the yellow no reaction means. And then what do the pink yeses mean? It means, yes, there is a reaction because Y is more reactive than X, therefore it will, yes, it will displace X. Similarly, Z is more reactive than X, therefore it will react. It will displace X. So make sure you can understand this table.